So welcome. Start your engines. Managing software quality in Mode 2 world. Are you in the right room? Yes? This is what you came for? Good. So my name is Joost Visser. I work at the Software Improvement Group. I'm head of research there. Has anybody ever heard of Software Improvement Group? Yeah, some, not that many. It's the Software Improvement Group is world famous in the Netherlands, I think. But I will explain to you what we do. We are a small company that is very passionate about measuring software. And we have a reason for that. We measure software, any type of software we can get our hands on to see whether it's any good, whether it's built well, whether it's according to craftsmanship. We do this for many, many customers, and the reason they ask us to do this is because they have decisions to make, sometimes at a very high level. Do we actually continue with this project? Sometimes at a very detailed level, what are we going to do with this module here? So that's what we do. We measure and we translate what we find into actionable recommendation to our customers. So this is a little bit of background you need to understand why I'm standing here and telling you all this. And I will get back to that a little bit later. So let's get started. Why are you here actually at Mendix World? Why are you using Mendix? Anybody? Is it because you want to go fast? I hope so. That's what it's intended for, right? Mendix lets you go fast. So we all want to go fast. We all want to be agile. We want to cut corners and get there as fast as possible, arrive before the others. So that's what we want to do. That's why we're building the software we're building. And that's what we want to do. And that's great. But there's also something we don't want. We don't want this to go wrong. When you're racing, of course, you take a lot of risk. You're going fast, and this might go wrong. And this is a crash. This is the worst thing that can happen, perhaps, because you don't get to the finish line at all. You know, your project gets cancelled. But it might be different ways in which things can go wrong. If you simply cannot sustain the speed you want, because, well, you cut a corner a little bit too fast, and now there's something in the wheel that doesn't allow you to arrive at top speed anymore, or you lose your grip, or you blow a tire, then, well, all the others get there before you, even though you might have started very fast. So that's what this is about. This is about going fast and keep going fast. So Gartner wrote about this, also in regards to bimodal IT. And yeah, they say anyone can go faster, but the challenge is to go sustainably. So to go fast sustainably. And yeah, what does that actually mean, right? To go fast sustainably in software. So how long do you want to go fast? What do you want to do? Why, you just want to add more and more and more, right? No, not quite. You do want to add more, but while adding more, you also have to sometimes pivot and do something different. You have to trace back and say, no, this was not right, or you find a bug, or you have to do something different. The users change their mind, or they have new requirements. So it's not just about adding more, it's also about managing to change direction. So how can we go fast sustainably? So let's go back for a second to the analogy with racing. So in racing, feedback systems are critical, right? So it begins with the steering wheel, right? You have to be able to control this thing. The speedometer tells you a lot of information that you will process and then decide where to steer or put on the brakes. But it goes a little bit further than only in the cockpit of the car. It's not just the developer, so to speak. It's a little bit more. It's the entire team. So you have to be able to decide whether to change your tires or not, and at which moment in the race. So if you really want to go fast, want to be high performant, also in software development, you need this a little bit. You need sensors. You need to have dashboards. You need to have data to base your decisions on. Whether these decisions are at the level of do I program around this corner or around that corner, but it can also be a much higher level, whether you decide to create a new app or add the functionality to the existing app. So in racing, this is evident. You need feedback systems, and the more and the better you can make your real-time decision-making while you are racing. And this is how you want to compete. So in software systems, well, how does that work actually? So at the Software Improvement Group, we've been doing this for many years already. We started in the year 2000, and ever since then, we have been measuring all the software systems of our customers. So we measured by now about 8 billion lines of code and given feedback on that to all the stakeholders around, developers, architects, testers, etc. So we have some experience with that. We have actually arrived at a pretty good methodology for doing that is quite well accepted and used by all our customers, and that helps to rally around. So I will tell you a little bit about that later. But of course, then an interesting thing is, okay, how do you do this in Mode 2? Because we've been doing this for years. We started by analyzing COBOL code and Java and everything you can imagine by now. I think we cover about 180 technologies by now. But how do you translate what is sustainable and what is quality in the conventional world to the Mode 2 world? So let's see. So to lead you into that a little bit, so one of the things we believe in strongly is that we have to, if you want to go fast, want to be agile, you have to be agile not just in your processes, you have to be agile in your product. So we put product over process. We want in software development, the product is key, and in everything around it, all the IT processes, they're useful and necessary, but don't lose sight of the product. Put the product first, make sure that you can actually see what's there. And this is, of course, a huge challenge in software. You cannot really see what's there. Yes, I'm a developer, and I see code. Of course, I program it, I control it. But on the other hand, the other guy is also programming. I'm not quite seeing what he's doing. The other team is doing things. If I'm a manager, well, I might be able to read code, maybe not. I might be able to understand what all these guys are doing, but it's very indirect. If you can make that visible, if you can somehow enable direct observation of what's going on, that's where we want to be. So the road there is to measure software artifacts. I write here software artifacts because it's not just about code in the classical sense, of course. There's many more artifacts nowadays that are relevant. And definitely, of course, for the Mendix platform, you want to look at something else than just plain code. You want to look at the app models. So, and the ultimate goal of that is to be able to enable not real-time decision-making as you have in racing, right? You have to steer now and not half a second later, but right-time decision-making, which is both more challenging and less challenging in a way than real-time measurement. So how is it less challenging? Well, it doesn't need to be real-time. You have a little bit of lag. I don't need to have it in the very same second that I type something. I have to have it maybe only in the next hour. But it's more challenging because you also want to anticipate. You want to know what's going on down the line. You want to have a feeling for what I'm doing, how this will impact myself when I'm developing on the same thing in 2 months, but also when I'm already to a different team and a different challenge, somebody else will take over. So you have to also anticipate. So that's why I call it right-time decision-making. So let's try to give you a bit of an example of that. You'll understand I'm simplifying a bit here, but just to give you a feeling for that and make it a little bit more concrete. So this is how in software development you can control speed and why you should control speed. Top graph is what we call maintainability, the technical quality, the amount of technical debt in a way of a software application. So it's going down here. So this is an example where month over month we measure and we see, okay, it starts off nice and dandy, greenfield, new application, of course, good quality. But as we're going along, sorry about that, it goes down. So it's not managed, right? The software quality it slides away, it erodes. Technical debt creeps in. On the other hand, you see what's happening in the progress. Progress just measured as volume of the product. Are you creating more? Goes nice and fast. In the beginning, tapers off. what is the mechanism here? Of course, if your quality goes down, the changeability, the adaptability of what you are making goes down. So this is a very weird thing in software. It's somebody called it the evolution paradox. As software evolves, it becomes less evolvable, right? The more changes you make, the harder is the next change to make. That cannot end well, right? That's not sustainable. So to make that end well, you have to make sure that every change you make, the changeability doesn't decrease, so the quality remains high. So that might mean, for instance, that at some point you have to, adjust your speed here and not do the next feature and the new requirement and add the new functionality right away, but sit for a moment to refactor what you're doing and make sure that you're in the right position again before going forward. Very counterintuitive if you just want to go faster. Very difficult to explain if to the others around you it's not visible what's wrong, right? If this top graph is not visible, why would you go a little bit smaller? Why are you slower? Why are you refactoring? Why are you not picking up the new ticket yet? Well, because I'm closing off my previous ticket in the right way. Well, what are you doing? So if it's visible, that helps. You can explain what you're doing. And this is, on the day-to-day, but it's also maybe at some point we need a refactoring sprint. And you have to be able to rally around that refactoring sprint, the entire team and all the other stakeholders as well. Another example. You can control quality, not just not just speed, you can control quality. So, I'm going to go for that water, by the way. If you have a measuring system in place, it allows you, of course, to see over time what you're doing, and that's why I showed you the trend lines before this, but you can also compare among options. So here you see actually something we have measured in the past. These are 3 open source systems. Sorry. I need this. 3 open source systems. And you see, this is very concretely what happens. We measure, and a star rating comes out. A star rating, what does that mean? Well, the star rating, of course, very intuitive. The higher, the better. And there's an entire system below that that actually has some meaningful measurements, like the volume, like duplication, the size of units, complexity, all kinds of elements like that are being measured and aggregated into this model. You can have the full drill down to the code if you want. And at the top level, you can see, okay, Apache Tomcat, apparently 2.5 stars. So it's kind of in the middle of the industry. Because these star levels, we have calibrated them against these 8 billion lines of code that we have collected by now. We know what is market average. So we've calibrated the system that you get 3 stars if you're in the middle of the pack. If you're the leader of the pack, you get 5 stars. If you're trailing behind, or you've crashed against the wall, so to speak, then you get 1 star. So that's what's behind this. And you can make comparisons and see which systems, which applications are in need of some improvement and which are not. So this is a way to control quality. You see the quality, you can measure it, and you can act on it because you can drill down and you can find the problems and change it. Third example, complexity. Well, complexity, of course, can mean anything to anybody, but one way of looking at complexity is looking at, how is the architecture of the system, the code organization, how is this organized actually? And is it highly complex or it's nice and simple? And well, here you see an example of the structure of a system that we have recovered. This is actually a JUnit, for those who don't know it. And you can't really tell, but I assure you it's on the slide. So there's different colors of the arrows, and the red arrows, for instance, give you cyclic dependencies. So this is typically something you don't want. Cycles. That makes things more complex. It's not always the case, so you can actually distinguish which dependencies are wanted and not wanted. So when in the beginning you dream up an architecture with certain constraints in it, you can later on check whether the implementation actually conforms to that. And that's, of course, very valuable. And because one thing might be, okay, you did the implementation wrong, you have messed it up, it has eroded somewhere. Might also be that your initial dreamed architecture was not the right one. That when it hit reality while developing, it actually calls for a change, or simply you have changed your mind and you want, for instance, to change this into a plug-in architecture or something like that, and you set down a new architecture. So this allows you to control for complexity. So that's how we do it in general. At least some parts of that. Can we do it in Mode 2? Can we do it for Mendix? And of course, yes, we can. This is possible. It's not entirely trivial. It can be done, and actually we did it. And I don't know if you were in the keynote. It was already mentioned there, and it's up and running. And there's quite a couple of organizations already making use of this. So it roughly looks more or less like this. I show you a little bit later in more detail. But if you want full detail on how this works and what's in there, you're very welcome at the booth in the middle of the room there, where the orange floor is. Some colleagues of mine, and I will be there later as well to show you everything you are interested in. So, how is this done? So, this is the type of things you get. I've tried to kind of put everything on of course, you get a nice interface where you can navigate and everything, but I tried to put it all on a slide to give you an overview. You get, of course, the star ratings with all the drill down behind it. You get your trend lines to see where the quality aspects are going, what's going up and down. And this is a technology profile. This as well. This is kind of for now, and this is for over time. So, because of course, you typically mix different things in, not just a Mendix application model, but also some CSS, HTML, Java, and JavaScript in this case. And you can see actually how much of that is there. And maybe when you discover actually how much that is, you think, wait a second, this is getting out of hand. So let's see, here there is actually 43% of the system is Java code. And well, it might be intentional or not. Of course, that is a decision you have to later make. You have to compare it with what your intentions are. But at least now you know. This thing will not grow without you noticing. You can actually put a stop on it if that's not what you want. The dependency graph I already told you about for Mendix. And here you can drill down to all kinds of elements in the model, the microflows and all these things, and see all the numbers attached to those for where you want to fix and where you want to order them on certain quality attributes. And in the end, all the way down, you will find a textual representation of your Mendix model, so that you can always trace back exactly how the measurement relates to your model. So you know exactly what is where, and you get the overview at that level as well. So basically what we did is we have taken the 15 years of experience we have in measuring, that we have already bundled into our measurement methodology and technology, and we've made it available in the Mendix platform. So we needed to, of course, tailor all the specific measurements we have to Mendix. That was an interesting challenge, and we managed, and it became really nice. I'm really curious to hear again from people like you who are intimately familiar with the Mendix models, how that resonates, if we really got it entirely right. So far we have got very good reviews on that, but we want to keep improving that, of course. We've been using the APIs to do this. This is, I have to say, a really great feature. I think we were the first using the APIs that are available now for doing this. So we basically plug into the platform through those APIs to make this possible, and getting all the information we need to build up the measurements, etc. So it's in that sense completely integrated. It's hosted, so you know it's there's no deployment issues there. And additional to kind of the technical part, of course, you have to also make this part of your way of working. So what we've also done is we have created what we call a starter pack, which consists of a number of training modules where you can get onboarded very rapidly, and we explain exactly and work with you to find out how you integrate this exactly into your agile way of working, so that you make the most out of it, because a tool is just a tool. You have to, of course, understand what it's trying to tell you, understand how to work with it. And that's done in our starter pack. And well, here's a couple of customers that are already using it at the moment. Animations. Basically, recapping, if you want to go fast and you want to go fast sustainably, you don't do that on your own, right? So I already mentioned the team and the pit stop in the racing analogy. And in software development, it's the same. You don't do this by yourself. It's not just for the developers. It's also for architects, managers, and of course the implementation partners have a special role here as well. And what do you do as developer? Of course, you focus on your part of the problem. So what you do is basically you run your regular quality checks. Actually, they're run for you. You check them. You check back with these checks. You can drill down to diagnose. You know what to do. You fix it, and of course, after fixing, you can check again. So you have your tight feedback loop. This is all about feedback systems. It's a tight feedback loop for the individual developers to know what the consequences are. If you're focused on building functionality, you might be forgetting about the technical debt you're putting in there, but this will remind you and you get the opportunity right away to fix that, rather than, you know, down the line at some point you discover that things are going slower and you wonder why. So you can do this up front. As I already showed as well, if you are the architect on the team or outside the team, depends how you organize this, you can check, is this actually according to the way it was designed? And you can drill down again on the non-compliances. You can find out where it's non-compliant. You can go all the way down to the level of the artifacts, of the models, of the code, to see what's going on there. And okay, you might not want to fix your implementation. Sometimes you need to fix your architecture, actually. It's a very important thing to keep in mind. When you're managing a team or managing a set of teams, it can help you to set clear goals. It's very important that not everybody has a different interpretation of what good enough means in terms of technical quality. You need to have a kind of shared set of criteria there, because otherwise, yeah, that doesn't work very well. One person thinks he's done, the other one thinks he's not done. So this gives you a definition of done, so to speak, for technical quality. You can just agree on, we're going for 4 stars. This is actually very common among our customers. Typically 4 stars is what they want for new applications. That's where we want to be, and everywhere where you deviate from that, well, that's the agreement in the team and agreement among the teams that you act on that as fast as you can to bring it to that level. And that helps immensely. And of course, for implementation partners, from this perspective, this is a great way to demonstrate that you're not just providing the nice functionality that people are asking for, but that you're actually doing it sustainably because you also have the technical quality in place. And that's not an extra, it's a prerequisite to keep delivering this functionality, of course. So if you want a sustainable relationship also with your customer, this is a great way to show that you are actually doing that you are not programming in the dark, so to speak. You're not developing in the dark, you know what you're doing, and you can demonstrate that. And where necessary, you can actually make visible to the client why you're doing certain activities that otherwise are not explainable. Why are you refactoring, changing things that don't give me new functionality? All right. Final slide. As I said, start your engines. You want to go fast, but you want to keep those engines running, and you want to keep them running at high speed. And that's not just for the next month, not the next 2 months, but maybe for the next year. And you have to be not just fast, you have to be agile, right? You have to be able to change. And this is, it's very important to have a good, you have to make your technical quality level visible so that you can act on it, keep it high, and make sure that the speed in the future will be sustained. So this is what I meant by the anticipation, the right time decision making. If you let it run for a while and then you discover you're not going that fast anymore, it's become too complex, it's become too hard to change, you're too late. You want to do this in process, not after. Very important issue, I think, is getting a single source of truth. No debates about, do we like it this way? There's enough to be talked about on the functionality level. This makes it simpler to agree on where you stand on quality, gives you a tight feedback loop, and it also you can show this not just to those intimately familiar with this application that are working on a day-to-day basis, but other stakeholders that are involved with it. They can look at it and agree with you on what the right level of quality needs to be. So this allows you to optimize your speed and your agility, and keep that going. So that's my message. Maybe we can discuss a little bit about that. Is this something that resonates with you?
There you go.
I think it's a very great way to raise awareness among stakeholders about the quality. I have a question about the dependency analysis.
Yeah.
I think that in practice architects are using kind of industry standard architectures, layered architectures. I'm wondering if it's possible to configure your solution to actually recognize those layers, and this way make even a more precise advices about the violations.
Yeah, so that's possible. We don't have that active now in the AQM. We do have it active in our general solution. One reason is that this is kind of an advanced feature, right? This is something you want to start doing once you familiarize yourself with everything that's available out of the box, and then you start putting in these things. And the basic thing you do there is basically define which of your dependencies and which of your modules are desired and which one are not. And that gives, and you can, this way you configure your own feedback system, so to speak.
Thank you.
Further questions? Anyone? Nobody? Yes.
Is there any performance overhead when you're running this? Assume you need to run it against your production environment.
No, so you do this in development, right? So if there's
Have the same data flow. Does it rely on the production like data?
no, so there's no. This runs instantly almost. The only thing that influences how fast this runs is how large your model is, but that's not an issue at all, and it does not influence in any way the performance of your solutions. Not at all. This is done before production. So this is also what I mean by write time, right? This is, you want to have this information development time. Yeah. So thank you very much. We will be at the booth over there, so if you have any further questions, want to see something going, want to know any details, you're very welcome. Thank you.